Okay, this video is basic multiplication and division review, so it's gonna go rather quick and I'm gonna just overview and explain things. So, multiplication, when it's written like this, you gotta stack it where the 3-digit numbers on top and the 2-digit numbers on bottom. So we have 492 times 38. All right, and then you go the ones place multiplied by each of these. So 8 times 2 is 16. 8 times 9 is 72. Plus that 1, you have to add what you regroup. So that's 73. 8 times 4 is 32. Plus the 7 is 39. So just like that, our 8 is done. We no longer need it. And we no longer need what we regrouped. So now we're doing the same thing with our tens place, the 3. This 3 is really a 30 because it's in the tens place, so we're gonna put a 0 here. So now we're doing 30 times 2, but instead of thinking like it's a 30, we can go back and think of it like a 3 because we put that 0 down. 3 times 2 is 6. 3 times 9 is 27. 3 times 4 is 12, plus 2 is 14. Just like that, we did our 3's. So this line right here is our 8 times 492, and this line right here is our 30 times 492. We want to do 38 times 492, so we have to add this together. And then there's your answer. Done. Okay, now on to division. So, we have our standard algorithm. The first one goes in the box. And then you go digit by digit. Divide, multiply, then subtract. Bring it on down and bring it on back. Can 6 go into 1? Nope. So you put a 0. 0 times 6 is 0. Divide, multiply, then subtract. Bring the next number down. And here's where a lot of you guys get stuck. You forget the last part of the wrap. Bring it on back. So I start all over again. Instead of 1, I have 19 now. So can 6 go into 19? Well, let's count. 6, 12, 18, 24. 24 is too big. 6, 12, 18. So it can go 3 times. 3 times 6 is 18. Divide, multiply, then subtract. Bring the next number down. Can 6 go into 12? Absolutely. We know that. Goes in there twice. 6, 12. Subtract. We have no remainder. So 192 divided by 6 is 32. Here's our answer. Okay. Now, let's look at this one. We have 676 divided by 13. So we're going to use standard algorithm again. Can 13 go into 6? Nope. Well, can 13 go into 67? Yeah, I have no clue how many times. I can't count by 13s, so I'm going to guess to the side. I'm going to guess 5. I like to start with 5 because it's directly in the middle. If it's too big, I know I have to guess 2, 3, or 4. If it's too small, I know I have to guess 6, 7, 8, 9. And remember, I'll never go over a one-digit number. 5 times 3 is 15. 5 times 1 is 5. Oh, look at that. So, 65. That's as close as we can get without going over. Divide, multiply, then subtract. Bring this next number down. Can 13 go into 26? I think we know the answer. Twice. There you go. Now say if you still get mixed up with the wrap and you're not sure and you want to use partial quotients or the hangman method. That's perfectly fine. You do you, boo-boo. As long as you get it right. So hangman method is like repeated subtraction, but you're subtracting smarter. You're taking chunks out. So our chunks that we always use are times 3, times 5, and times 10. 13 times 3 is 39. 13 times 5, which we just figured out, is 65. If you don't know them in your head, please write them to the side. 13 times 10 is 130. So this is our box of numbers. which one would take the biggest chunk? Now you can either start subtracting 130, or you can work smarter and going, wait a second, if I add a 0 here, which means I add a 0 here, I can take out 650. 13 times 50 would be 650. Because 13 times 5 is 65. You add a 0. Now you have 26, and again, you guys should know that is 2. 52. You get the same answer. Now again, this only works if you use your magic numbers and use them smart, like putting your zeros, or it's a lot of subtracting. What's scary about this one is sometimes you'll subtract all the way down, and if you make one silly subtraction error, the whole thing's wrong. All right, so now let's do it this one. So the first one goes in the box. Can 21 go into 1? Nope. Can 21 go into 10? Another no. Can 21 go into 108? Yep, so I'm trying 5. 5, 10, look at that. Can 21 go into 30? Yeah, once. Okay, I have a 9 left over. Now, there's nothing left to bring down, so this is my remainder. Now, let's talk about this. Sometimes your remainder will be your answer. Sometimes you have to round up. Sometimes you have to drop it. So, if this was a word problem, and I said I had 1,080 students, and a bus can only fit 21 students, that means I'd need 51 buses that would be jam-packed full and 9 kids left. So would you want me to order 51 buses and these 9 kids have to walk to the field trip? Or I should order 52. So sometimes you have to include the remainder, and your answer would have been 52. You had to order 52 buses. Now say they asked, well, how many kids would be on the last bus? Well, the last bus would be that extra bus I ordered and would only have 9 kids on it. So sometimes the remainder is your answer. And then you could say, okay, how many full buses are there? And that would be the 51. So you really have to pay attention to the wording of the question. All right, this is our first review, so we're starting off pretty basic.